Hi. Thanks for coming. So my name's Nguo. A scientist working in nutrition at Monash University. So my research is looking at energy balance and metabolism and how to optimize health and well-being. So first of all, I want to explain what energy balance is. So just imagine that I'm a scale, a balancing scale. This is energy in, okay? So energy in means like the calories we consume, which provide us with energy. And those calories come from like food, okay? Energy out on the other side is the energy we use day to day, like for physical activity, running, walking, hiking. Our brain uses energy, so that's energy out, okay? So if we eat more food than we use, that means we'll gain weight, okay, because of the excess energy which gets stored as fat. If we exercise more, okay, than we eat, then we lose weight. Energy balance means that we're in balance between what we eat and what we use, and therefore we hopefully should maintain our weight, okay? So energy in is from the food that we eat, okay? They provide us with calories and energy. Energy out, I've already spoken to you about what energy out is. One of the components is exercise and physical activity. So we use energy like for running and walking, and we need that energy from the food that we eat. So there's actually two other components of energy expenditure. You may not have heard of them, but one's resting metabolic rate. So it's the energy that our body uses while it's at rest to maintain our basic functions like brain, thinking, digestion, breathing, kidney function, the energy that's needed to maintain muscle. So even when we're resting, our body's actually using energy to keep ourselves alive, and that's called resting metabolic rate. Now, the greater muscle you have, the greater resting metabolic rate that you have, because muscle uses a lot of energy. So that makes up about 60 to 70% of your total daily energy expenditure. Alright, so we've got that, and then we've got physical activity. The third component of energy expenditure is something called meal-induced thermogenesis. So it's quite a long word, but basically it means the energy that our body uses to digest, process, and store the food that we eat. So every time we eat, we're actually using energy to metabolize that food. Okay? So that makes up about 10 to 15% of our total energy expenditure per day. Right? So they're the three main components of energy expenditure. So that's just a background about energy expenditure and energy metabolism. So
so that leaves very little of that percentage to like exercise.
Yeah, so typically, like every adult would probably spend about 20 to 30% of their total daily energy expenditure as physical activity. Now, of course, that would vary. So if you're an athlete, if you're really active, it might be more. But a typical like average adult, I don't know what you can call average, but day to day general adult, about 20%. Again, it can be less or it can be more depending on how much activity that you do. So that's just a bit of background. Now, my area of research is looking at whether or not there are differences in energy metabolism between different populations and different like ethnic groups. And one example is, I'll give an example of ethnicity.
So this is metabolism like speed.
Yeah, and how we use our energy. Yeah. So I want to find out if there's differences in energy metabolism or how we use energy between different ethnic groups and different types of populations, to explain why certain populations may have more fat and may store more fat than others and may be at higher risk of certain diseases than other people. And I want to find out if it's related to energy metabolism or not, and how people use energy. So one example I want to give is that I'll give an example of someone from an Asian background compared to someone from a Caucasian background. So an Asian person of the same height, weight, and gender as someone compared to someone of a Caucasian background of exactly the same weight, height, and gender, so same BMI. I'm not sure if you've heard of body mass index. Yep, so a Caucasian person and an Asian person of the same BMI, on average, the Asian person actually has more percentage body fat than the Caucasian person. Yep. You wouldn't have guessed. It's really surprising. And not only that, not only more percentage body fat, but also more body fat around the organs or around the stomach area, so known as the abdominal fat. or this sort of fat. Now this fat is what we call like the dangerous fat because it's associated with diseases like heart disease and diabetes. So I want to know, okay, why is it so? Why is it that for the same BMI, an Asian person has greater risks of like metabolic diseases and more fat in their body than a Caucasian person? Like, I'm interested in that, and I'm interested to see whether or not that's related to maybe a dysregulation in like energy metabolism. Is it because they're not, using the energy as efficiently as a Caucasian person? Is it because like they're using less energy and therefore the energy that is in excess is getting stored as fat in the body, and that's why they may be at greater risk of developing certain diseases and also like cancer. So that's the area of my research, and in particular I'm looking at meal-induced thermogenesis, so you can actually measure that in the lab. So using a method called indirect calorimetry, where a person lies on the bed and then they have a hood over their head, and then it captures the oxygen they breathe in and the carbon dioxide they breathe out, and from that you can actually measure how much energy the body is using after someone's eating a meal, and that's how you measure like meal-induced thermogenesis. So I want to in particular find out whether or not there's a difference in like how someone uses energy after a meal.
Is that because energy is expended as carbon dioxide?
Yeah. So there's a lot of like kind of physiological mechanism, but that's the essence of it. We measure the oxygen and also carbon dioxide, and then we do some calculations, and that tells us how many calories the body is actually using. Yeah. So that's pretty much what my research is about, trying to further understand like if there's any differences in energy metabolism or how the body uses energy, to try to help explain why the difference in body composition, or meaning like how much fat mass or how much lean mass we have in our body, and also why the differences in disease risks, for the same BMI for two people of different ethnic backgrounds. Yeah, so it's not been done before, this measurement of meal-induced thermogenesis and ethnic differences, so it is quite exciting, and I've only just started the study, by the way. And hopefully I'll get results maybe later in the year or early next year. Yeah, thanks so much for listening.